Find the partial fraction decomposition we'd need to use in order to integrate this expression here. Now, they're not saying integrate, they're just saying find the partial fraction decomposition. Find the partial fraction decomposition. Okay. So, what have we got? Well, really, we just need to sort of break 11x squared minus x plus 17 over x squared plus 2x plus 3 times x minus 4 into its smaller, simpler rational expressions. Okay? Now, when we look at this, somebody's been quite nice, and they've already factored this for me. Okay? If we check degree 1 polynomial times degree 2, the bottom is degree 3, the top is degree 1, so there's nothing we need to do. This is proper. We don't, no long division required. When somebody hands me something like this and it's already factored, usually I'm a trusting sort of person. I imagine that if you could break this quadratic down further, if somebody was going to factor some of it, why not factor all of it for me? So I suspect this is an irreducible quadratic, but a suspicion is not enough, right? So we should probably make a little note. Okay, is this actually irreducible? How do you check that? Right, if you got ax squared plus bx plus c, how do you know if it's irreducible? A quick calculation you make is b squared minus 4ac. If that's less than 0, hooray, it's irreducible. I'm pretty sure this one will be, but let's check. So our b is 2, so 2 squared minus 4 times a times 3, our c here is 3. And you get 4 minus 12, negative 8. Okay, that's negative. So yes, this is irreducible, but I can back that up. Right? I can back that up in case anybody said, how did you know? How did you know you could skip that? Why didn't you reduce that further? It's irreducible, and I know why. Because I tested. Right? It's important. It's important to sort of be able to flex your math might that way and say, yes, I know for a fact it's irreducible. I'm not just relying on the kindness of the stranger who factored this for me. Okay, so with that said, if we got an irreducible quadratic, how does that change how we set things up? We got 11x squared minus x plus 17. Minus x plus 17. And it was x minus 4, I'm pretty sure. And then x squared plus 2x plus 3 here as well. Just double check. Always good to check before you launch into a lengthy calculation. Okay, good. So, what does the partial fraction decomposition look like? Okay. For each irreducible quadratic factor that we've got, we add 2 new constants. So we get ax plus b up on top here. We still have a linear term as well. So c over x minus 4. And our goal here, we're done the question, because they didn't ask us to integrate, we're done the question when we know what a, b, and c are, and we can confidently say, yeah, a is 3, and b is negative 8, and whatever they are. Okay? I have no idea if a is 3 at this point. Okay, so what I usually do at this point, I don't like working with fractions, I don't like rational expressions, so I'm going to multiply both sides by x squared plus 2x plus 3 times x minus 4. You just multiply it by the denominator, because that'll cancel out here, and just leave us with 11x squared minus x plus 17. But if we multiply each of these by x squared plus 2x plus 3 times x minus 4, it cancels out with part of the bottom, and you're left with c x squared plus 2x plus 3. And if we're multiplying by x squared plus 2x plus 3 times x minus 4, the quadratics would cancel, and you're left with ax plus b times this x minus 4 here. All right, so I see that, okay. Now, these are 2 polynomials that are the same, right? Because we've got this equal sign here. So they're effectively the same. So what can we do? How can we find a, b, and c? Well, one thing we can do, we can expand out on the right-hand side. We can multiply things out. We'll get ax squared plus bx minus 4ax minus 4b plus cx squared plus 2cx plus 3c. Okay? And we can collect like terms. So we've got a plus cx squared, right? There's ax squared, there's cx squared. In terms of the x's, we've got b plus 2c minus 4a x's. And then we've got 3c minus 4b. Now I'm grouping these together so that we have very clearly the coefficients for x squareds and x and the constant term. Now why does that matter? Well, we know that this polynomial is equal to the thing on the left-hand side, which is 11x squared minus x plus 17. But the nice thing about polynomials is one of the many, many reasons there are to absolutely love and adore polynomials is that two polynomials are only equal. It's a 3c. No, it's a 2c. Yep, 2c. Okay. One of the things to love about polynomials is two polynomials are equal only if their coefficients are equal. Just want to make sure we're copying this properly. Okay. Oops, wrong one. And then we got, oh, that's brown. That's what happens when I accidentally hit a button. Minus 4b. Right? So what does that mean for us? That means that a plus c has to be the same as 11. No choice. 3c minus 4b has to be the same as 17. And the really complicated one, b plus 2c minus 4a, that coefficient of x there has to be the same as negative 1. Okay? It's got to be. No other choice. I'll make that c look a little more c-worthy. Okay. So, what can we do from there? Right, well, now we can try and solve for a, b, and c. So we could, for example, we could take this first equation and rewrite and say, oh, c is 11 minus a. Or you could solve for a is 11 minus c. It doesn't matter. Okay? But we can take that and put it down here in this last equation. So that turns into 3 times 11 minus a minus 4b is equal to 17. So that's 33 minus 3a minus 4b is 17. And subtract 33 from both sides, you'll get minus 16. Multiply by negative 1 on both sides, you get 3a plus 4b is equal to 16. Okay, that's kind of interesting. We can do the same thing. We can plug this c in here as well. We can say, all right, we've got b plus 2 times c, so that's 2, 11 minus a minus 4a is negative 1. And we can expand that out. We can say, okay, b plus 22 minus 2a minus 4a. Oops, that's an a, not a b. Is negative 1. And what can we do? We can subtract 22 on both sides and say b minus 6a is negative 23. Right? So that's another equation. In fact, we can use that equation to solve for b. So b minus 6a is negative 23. Okay. Well, that means b is 6a minus 23. And we can take that and put it in this last equation here. So 3a plus 4b, which is 6a minus 23, is equal to, what was it, 16. Okay. So we get 3a plus 24a's. 4 times 23 is 92. Because we remember our multiplication tables. Okay. And let's see, that's 27 a's is equal to 108. Divide both sides by 27, and you will get a is 4. Right? A is 4. But now that I know what a is, I can come back here and figure out what b is. B is 6 times a minus 23. That's 24 minus 23. B is 1. Right? We can also come back here and figure out what c is. C is 11 minus a, so that's 11 minus 4. C is 7. So a was 4, b was 1, c was 7. And what did the question ask us for? It asked us for the partial fraction decomposition. So let's actually write it out. But we got our coefficients, so we are effectively done the question. So it was ax plus b over our irreducible quadratic. There we go. And then c, which was 7, over our linear term. There we go.